Cryptography by Barnett. Definitions of cryptography is secret writing, the enciphering and deciphering of messages in a secret code or cipher, the computerized encoding and decoding of information. Easily read data is called plain text or clear text. Clear text usually refers to the lack of protection from eavesdropping. Clear text is rendered as ASCII. Plain text supports ASCII characters. The file extension is txt, and here are some ASCII characters. Encryption. An encrypted message is called ciphertext. This text is unreadable. Encryption is used to ensure that no one that is unauthorized can read your messages. It is the best way to ensure that your text is secure. Decryption. The process of turning ciphertext back into plain text is called decryption. You have to have a secret key. You have to have a secret key or password to decrypt it. Here is an example of the process. Select the key and encrypt. Give key and ciphertext to receiver separately. Use key to decrypt ciphertext. It starts off as plain text, then encryption, ciphertext, decryption, and back to plain text. Cipher, a code in which each letter or number is represented by another letter or number. This is a clock cipher, has numbers and letters. The Lorenz cipher machine. This is the Lorenz model SC42. This machine served as an inline to a standard Lorenz teleprinter, and it was used by the Germans in World War II and was used for high-level communications. Referred to the German teleprinter traffic as fish and the machine as tunny. There are a lot more interesting facts about the Lorenz cipher, and you can go to www.codesandciphers.org. This is a draft diagram of the Lorenz cipher. These are the Lorenz rotors. This is the Enigma machine. It was different from others because it was electrical. This is how it changed its plain text into code. One good thing about this machine was if it fell into the enemy's hands, it would be useless to them. The secret to these machines were rotors, which were actually like gears. It uses a polyalphabetic cipher, and it's a type of substitution cipher. A great tutorial on this Enigma is on YouTube at this link. Substitution ciphers are easiest to implement, but also easiest to break. Polyalphabetic cipher operates on a single letter. Monoalphabetic substitution is one where a letter of plain text always produces the same letter of ciphertext. Here is an example of monoalphabetic cipher. It goes in as plain text, erase the types and the cipher alphabet above. Then we get this code that comes out. Shift ciphers. The Caesar cipher is a substitute cipher, the earliest known tool for creating codes to encrypt messages, the simplest and most widely known. Caesar cipher is easily broken and in practice offers essentially no communication security. It shifts letters to the right by using a fixed number. Here is some examples of the Caesar shift cipher. By shifting the position in either direction, a simple sentence can be unreadable. Let's go to this web page to do a simple translate. I'm going to put in "my dog snores" and click the encode decode text. Now it is in, the words are scrambled. Click the encode decode text button again and it goes back to plain text. AES, or Advanced Encryption Standard cipher, is the latest chapter in history of cryptography and most popular for security work. It encrypts plain text in a series of rounds. It expands the key, not the plain text. This is an example of how it works. On the diagram. In, out. AES common applications are file encryptions, which help protect information on your hard drive. The other is email encryption. It helps protect your email while it's going through the internet. DES cipher. DES has a block size of 64 bits and a key size of 56 bits. It has been superseded by AES because the AES has a block size of 128. DES, or Data Encrypted Standard Cipher, is the dawn of modern cryptography. It's the first block cipher, has shortened key length, and here is a diagram of the DES block. Here are my references. Thank you for watching my tutorial.